The overwhelming power of nature. Floods, storms, rising sea levels. Climate change is already altering the face of our planet. Freak weather is no longer out of the ordinary. It's becoming the norm. Our planet's ice is melting, and that changes everything. Seas will rise, cities could be submerged, and millions may die.
There won't be any area near the coast that won't be hit hard.
It's inevitable that we're going to lose everything at the coast.
Now we separate fact from fiction to discover the real science behind climate change and the melting ice caps. Global warming. It's a term we hear all the time. But behind the familiar words is a frightening reality. Our planet is warming up, and the effect on Earth's ice caps is catastrophic. As temperatures go up, the ice is melting. Sea levels are beginning to rise. Around the world, ocean levels are increasing twice as fast as they were 150 years ago. In 2005, 77 cubic miles of ice from Greenland and Antarctica melted into the sea. For comparison, the city of Los Angeles uses about 1 cubic mile of fresh water per year. This is global meltdown. In 2001, scientists predicted that sea levels would rise by 3 feet by the end of the century. That's a big rise, enough to affect more than 100 million people worldwide. But now researchers like Bill McGuire, professor of geohazards, worry that the predictions might be wrong.
The official scenarios for sea level rise, if you like to call them that, were published in 2001, and they were based on research that was undertaken in the years running up to that. So they are completely out of date now.
Even conservative estimates predicted that over the next 60 years, rising seas would destroy 1/4 of all the houses within 500 feet of America's coast. Recent research paints a more disturbing picture. Sea levels could rise as much as 20 feet by the end of the century. It's a bleak, even terrifying vision. But this is what scientists believe meltdown could do to us all. To understand what will happen when the ice melts, scientists need to study the processes driving the meltdown. Advanced modern technologies can reveal our planet's ancient history. By studying how things have changed in the past, they hope to predict our future. Sea level rise is nothing new. We know that in the ancient past, sea levels have been both higher and lower than they are today. It's a natural cycle, driven by the melting and freezing of the polar ice caps throughout Earth's 4.5 billion year history. When the ice caps melt, they release water into the ocean. When they freeze, they take it out again. Earth's climate alternates. There are ice ages when the temperature drops and the ice caps freeze and expand. And there are interglacial periods when the ice caps melt and release water back into the oceans. The cause of the cycle is the Earth's rotation around the sun. Earth's orbit around the sun varies in a number of complex ways. The most important is that it changes shape. It's not always a circle. Through a cycle lasting about 100,000 years, the orbit goes from being almost round to being stretched into an oval shape, then back again. In the more elliptical orbit, we travel millions of miles further away from the sun. Less sunlight reaches the Earth, and an ice age is born. Right now, our orbit is circular, not elliptical, and we are in a warmer interglacial period. But something is wrong. The ice is melting too fast. One of the places where that melting is running out of control is Greenland. Greenland, covering an area of 836,000 square miles, with ice of an average thickness of nearly 1.5 miles. Greenland contains 600,000 cubic miles of ice. and it's melting. Professor Conrad Steffen's job at the University of Colorado is to figure out what's wrong with the glaciers before it's too late.
We came first here on the Greenland ice sheet in 1990, where we set up a permanent camp on the ice, and the main objective was to measure the climate.
Each year, Steffen treks across Greenland, checking his remote weather stations. These beam data via satellite to his computers at Colorado. The news isn't good, and it's getting worse. Since 1990, the average winter temperatures in Greenland have risen by 46.4 degrees Fahrenheit. The Greenland ice sheet loses 275 billion gallons of water every 40 hours as icebergs crash into the Atlantic. 10 years ago, the melting rate was just a third of this. At Jakobshavn in western Greenland, scientists have tracked the movement of this glacier's edge since records began in 1850. Over the past 150 years, the edge has retreated 37 miles. That's bad. But what's worse is that the retreat is getting faster. The glacier is now disappearing twice as fast as it was 5 years ago.
Every day, this glacier pushes icebergs into the ocean that is sufficient to give fresh water used for the town of New York for 1 year.
Almost all the glaciers in Greenland that are south of the Arctic Circle have speeded up their discharges into the ocean. Glacier melting is nothing unusual. Their edges melt all the time, but normally the ice they lose at the edges is balanced by the amount of snow that falls on top. The snow compacts into new ice, so the glacier grows in the higher regions and melts at the edge. Scientists call this mass balance. Glaciers gain as much ice as they lose. This natural balance keeps the ice cap stable and sea level rise in check. For the past 10,000 years, that's how it's been. Our ice caps have been stable. But now the balance is off. The edges of Greenland's glaciers are melting faster than the rest can grow. Greenland's losing 20% more mass than it gains from new snowfall each year.
If this continues, as the balance shows, we are losing more mass. And this is what we actually discovered. This is happening right now. We are losing currently about 50 cubic miles. Can this be sustained? No. If it continues like this, Greenland ice sheet will lose mass every year by a certain amount, and the sea level will rise.
To get a detailed study of what was going on, NASA installed a global positioning system to monitor the elevation of the glaciers and track their loss of volume. What they discovered blew them away. Glaciers were melting faster than ever before. They were literally sliding into the sea.
Over the last few years, when we had the extreme warm temperature, the ice sheet actually accelerated not only 10-20%, but 50-80%.
In the summer of 1985, the glacier was moving toward the sea at just over 4 miles per year. By the summer of 2003, it was nearly 8 miles per year. It was clear that the process was accelerating. The glaciers were moving faster toward the sea. The reason was simple physics and the effect of meltwater. If you place a block of ice on a dry surface, the ice will move very slowly or not at all. But once the ice starts to melt, water gets between the ice and the surface, lubricating it. The ice is able to move much faster. This is exactly what was happening in Greenland. Warmer average temperatures were causing the top and edges of the glaciers to melt. Large pools of meltwater formed on the surface. But glaciers have huge cracks and channels within them. The meltwater drained down through these cracks to collect beneath the glacier. Here, it lubricated the junction between the glacier and the Earth, reducing the friction holding it in place and causing it to slide ever faster toward the sea. This is very bad news. If Greenland melts completely, it will release enough water to raise all the world's oceans by 23 feet. Until recently, scientists thought that was as bad as it could get. They were wrong. Greenland holds a lot of ice, but this isn't the only ice on the planet. Here, there are 500,000 cubic miles of ice. But Antarctica, the huge continent capping the Earth's South Pole, holds 11 times more. Scientists used to think that was no problem. The vast Antarctic ice sheets had a mass balance that worked. Antarctica is huge, mountainous, and cold. It should guarantee enough snowfall at the glacier's heads to balance out the melting at their bases. That's the theory, and that's how it's been for the last 10,000 years. Then in 2002 came evidence that the balance had changed. In just 3 weeks, a 1,250 square mile chunk broke away and vanished. There is now little doubt. The Antarctic meltdown has begun. The present Antarctic ice sheet accounts for 90% of Earth's total ice volume and 70% of its fresh water. It holds enough water to raise global sea level between 150 and 200 feet if completely melted. Until recently, we thought it was stable, but new satellite imaging technology is revolutionizing our understanding of our planet's vast ice caps and is teaching us that our world is not as stable as it seems. From hundreds of miles above the ice wastes of Antarctica, satellite data shows us something we thought was impossible. We believed the Antarctic ice was completely secure. But new research shows that it's breaking apart. Professor Eric Reno from NASA's Jet Propulsion Laboratory uses satellites to monitor the movement of glaciers of Antarctica with inch-perfect accuracy.
The senior people in my community, when they were going to the field in Antarctica in the 50s or 60s, didn't even know where the glaciers were.
In 2002, the new satellite surveys dramatically proved their worth. This is, or rather was, Larsen B, an ice sheet covering 1,250 square miles. It sat here for the last 10,000 years. Then, over a period of 3 weeks in early 2002, satellites watched as it completely vanished. Meltwater was again the culprit. But instead of lubricating the glacier, speeding its passage toward the sea, like in Greenland, this time, it literally split the ice shelf apart. Again, it was simple physics. When water freezes, its volume expands by 9%. Place a sealed glass bottle inside a freezer. It will shatter because of the pressure of the expanding frozen water inside. In Antarctica, it was this expansion that was doing the damage. Air temperatures in Antarctica are increasing 3 times faster than anywhere else in the world. This increase in temperature melts the surface and edge of the glaciers. Meltwater builds up and then seeps down into cracks and crevices inside the glacier or ice sheet. But unlike the Greenland glaciers, these cracks don't go all the way down to the rock below. Because it can't drain away, the meltwater builds up within the cracks, freezes, and then expands. The crevices are forced apart, and the glacier breaks up and slips into the sea.
And as a result, we saw a large fraction of Larsen B literally explode in 3 weeks from a series of very warm summers. It's quite an amazing event because this ice shelf had been around for 10,000 years.
Larsen B's disappearance triggered an even bigger problem. Now, The land-based glaciers dammed up behind it had nothing to prevent them from flowing down into the sea and melting.
These glaciers over here are sped up by a factor 8. They flow 8 times faster now than prior to the collapse of Larsen B.
The ice sheets are also being attacked from below. Over the last 50 years, the temperature of the sea around Antarctica has risen by over a degree. This warmer water circulates under the ice at the edge of the glacier and into cavities deep beneath the surface. Water conducts heat 25 times more efficiently than air. The warmer water melts the base of the ice sheet at a rate of 162 feet a year. As their foundations melt, the glacier's ice breaks off and floats out into the ocean. The combination of these two processes, the cracking and the deep ice melting, is breaking up the sea ice. The huge western Antarctic ice pack is becoming more and more unstable. Rino has calculated that the Antarctic currently dumps 26 cubic miles of ice into the ocean each year.
Antarctica holds enough ice to raise sea level by about 150 feet. We don't know how long ago it started to get warmer, but it's too warm for the ice shelves to survive, and the glaciers are accelerating.
As recently as 2001, scientists predicted the Antarctic ice sheets would remain stable throughout this century. Thanks to these astonishing images, we now know the truth. Antarctica is a disaster in the making.
As an observer, I say, well, you should not panic and run to the hills. But what we're seeing happening in the ice sheets today is a serious concern.
If the present meltdown continues unchecked, our planet will turn into something unrecognizable. Already, the average temperature is hotter than it has been for 1,000 years. It's getting warmer at a faster rate than ever. Many scientists believe that it's due to man-made climate change, but some point to the Earth's natural rhythms. The only way to discover what's going on is to study Earth's past climate. During the 80s and 90s, an international team of scientists went to the poles, where the history of Earth's climate is preserved in the ice. Richard Alley was part of that team. Today, he's one of the world's leading glaciologists. To Alley, ice cores are like time machines. They let him reconstruct climate changes from Earth's distant past.
If you go to Greenland or Antarctica or a mountain glacier and you drill into it and you pull up a stick of ice and you look at the ice, the first thing you'll see is that it will have layers. And you can go summer, winter, summer, winter, summer, winter, tell how much it snowed, tell how old it is.
Ice is a treasure trove of information. The layers not only tell us the ice's age, they also preserve dust from volcanoes and sand from drought periods. They can even tell us what the weather was like.
And so there's anything in the atmosphere is there, and you can measure it, including the atmosphere, how much CO2, how much methane, and what were the greenhouse gases doing.
The concentration of different isotopes of oxygen in the ice cores can tell us how temperature fluctuated in the past. Plot ancient temperatures against ancient levels of carbon dioxide from the ice cores, and the cause of our present crisis becomes crystal clear. The charts show two things. First, CO2 levels are directly related to temperature. Second, today they are rising fast. Carbon dioxide is one of the main greenhouse gases. These gases trap heat radiating out from the Earth's surface. The heat stays in the atmosphere instead of traveling out into space. The result is global warming.
So carbon dioxide is rising in the atmosphere now. What will that do? Well, we're pretty sure it means it's going to get warmer, okay? And here's one piece of evidence for that. We are looking in blue at temperature in Antarctica, and then in red at carbon dioxide in the atmosphere from 440,000 years ago up to today. In blue, we see the great ice age cycle of temperature. It was warm and cold and warm and cold and warm and cold and warm and cold and warm. which is linked to features of Earth's orbit. Things that tip the pole so it gets more sunshine, wiggles in the orbit, changes in the shape of the orbit, and the beautiful pacing that one sees is the features of the orbit. Now, what's weird about that is that Antarctica's summers were getting a lot of sunshine when it was cold. And that's been really hard to explain. Why do you get more sun and less warmth? And the answer is in the carbon dioxide. When it was cold in Antarctica, carbon dioxide was low. When it was warm in Antarctica, carbon dioxide was high. So as we see carbon dioxide rising, we expect warming.
The link between carbon dioxide and temperature is ancient. But today there's a difference. The present surge in carbon dioxide isn't just due to natural processes, it's also due to us.
1850, the Industrial Revolution turns on, and we start to see CO2 going up. We're burning fossil fuels, we're cutting a lot of trees, CO2 is rising. And it's still going up, and we're burning, and we're right there. And the change that's happened is very real, it's very clear. We know where it came from, we know what happened. There's no question that we've changed the atmosphere. These are possible futures. Will the economy grow like crazy? Will the economy tank? Will we clean up? Will we not clean up? All of these projections show that the change that's coming is very big compared to the change that's happened. All of them are still going up as they cross the year 2100. The world does not end in the year 2100. And so we have made a difference. We're going to make a bigger one.
If we do nothing to reduce emissions, carbon dioxide levels could rise by an average of 30% over the next 50 years. This could result in an average temperature increase of almost 10 degrees Fahrenheit. If this trend continues unabated, by the end of the 21st century, our planet will see higher temperatures than at any time for the last million years. As our planet becomes more crowded and polluted, understanding the forces that are driving climate change becomes ever more important. Until recently, no one knew how soon Earth would reach meltdown. Now, new evidence from organisms that died many thousands of years ago suggests it may be sooner than we thought. Most of the time, the sea is our friend, a place to relax, to buy property. It's estimated that within 3 decades, 75% of the world's population will live in the coastal zone. A century from now, cities from Shanghai to New York could be beneath the waves. The problem is ice. Icebergs, mountain glaciers, the huge ice sheets of Greenland and Antarctica. All of them are melting.
If our ice melts and the coast moves way inland, our cities will be reefs, and we will not be terribly happy with that.
Not all melting ice is a problem. It all depends where the ice is. If the melting ice is already floating on the sea, it doesn't pose a threat.
There's lots of ice on the planet, and only some of it raises sea level when it melts. So let's see what happens when we get too much heat on floating ice to start with. The level has not raised. Melting floating ice does not raise things. The ocean is not going to get filled up that way. But what would happen if we melted the glaciers of the Alps, the glaciers of Antarctica, or in this case, let's call this Greenland? What's going to happen if the heat turns on to Greenland and we start melting it? We could even have an iceberg break off of the side of Greenland or two and fall in. There's a couple falling in right there. And now what's going to happen when we're melting, when we're calving, when we're putting more in? And the answer is in. If you melt Greenland, or if Greenland flows faster and starts dumping more icebergs into the ocean, it will raise sea level. If we burn all the fossil fuels, if we raise the temperature a lot, if we melt Greenland, that there's going to be huge impacts on the coasts.
In 2001, a rise of 3 feet was predicted, but a new discovery suggests future rises could be as high as 20 feet. The clues to this new threat come from a tiny organism that lived hundreds of millions of years ago. A creature that still lives in many parts of the planet today. Coral. Ancient coral reefs reveal how high sea levels can rise after a meltdown. This kind of tropical coral only grows in shallow water, just beneath the sea surface. If it is left out of water, it dies. If it is too deep in water, it also dies. It's an excellent marker of sea level throughout history. If coral beds are found high above present sea levels, this means that at one time, the water level must have been higher. Dr. Jonathan Overpeck and his team at the University of Arizona have been studying ancient fossil coral reefs from 130,000 years ago. By measuring the elevation on the coral, he can determine how high the sea level reached.
You needed to have a sea level rise somewhere between 13 and 20 feet, perhaps a little more, higher than today.
These ancient corals show that the water level was up to 20 feet higher than today. By studying ancient ice core data, Overpeck calculates the average temperature of the Earth at the time when the corals were alive. He's surprised by the results. The Arctic summer temperatures causing those high sea levels 130,000 years ago were a mere 5 to 8 degrees warmer than today.
We figured, by the end of this century, that's when we'll cross this point by which will be warmer than it was then, and therefore we'll get all this ice sheet melting. But lately, the Arctic has been warming faster than we expected, and now it's possible we could get that warm by the middle of this century.
By comparing melt rates from today, Overpeck concluded that the western Antarctic ice sheet may have melted as well as Greenland. And the mechanism that caused this massive meltdown is exactly the same that Eric Rignon discovered happening in the Larsen B ice sheet in western Antarctica. Just like in Larsen B in 2003, the warm water of 130,000 years ago was melting the substructure of the glaciers and ice sheets.
What was happening apparently is that the ocean was warming, and that was melting underneath the ice shelves. And then as these ice shelves disintegrated, that allowed the ice sheet to flow out to the ocean. That was a big surprise for us.
It seems history is repeating itself. The mechanisms that led to meltdown back then are causing sea levels to rise again today. Scientists are worried. Earth could be heading toward a total meltdown far sooner than anyone thought.
A lot of us, myself included, are really quite concerned that we might be warming the Earth past a point where these big ice shelves and ice sheets could disintegrate, raising sea level in dramatic ways. We could cross that threshold before we have a chance to even understand the process, let alone stop it.
The Earth is approaching a tipping point, a point where climate change gets so severe that it could spiral out of control. A temperature increase of just a few degrees would have an enormous impact on human societies and ecosystems. That will cause the warming to accelerate to a point where the Earth cannot recover. If Overpeck is right, we are on the brink of planetary meltdown. Unless we take urgent measures to reduce greenhouse gases, we could be looking at up to 20 feet of sea level rise. Overpeck has created computer simulations that show the effects.
This image is focused on the New York metropolitan area, so right in the center is New York City. We can see as we move to 1 meter or 3 feet along the southern margin of Long Island, you can see Fire Island would start to flood out at this, and up along Connecticut and the Meadowlands in New Jersey.
A rise of 6 feet results in further flooding of the metropolitan area of New York. As the waters reach 10 feet, large areas of New York City would be underwater.
Here is going up to 13 or 14 feet, and you can see here a lot of red and a lot of pink, and the pink is where we've flooded areas that are heavily populated.
But New York at least has the advantage of some high ground. Florida has no such luck.
Most of the big populated areas of Florida are along the coast, and surprise, surprise, they're impacted by sea level rise. I'll just ratchet us up to 20 feet, and you can see that the amount of area flooded in Florida could be just devastating.
It's a bleak vision of the future. Sea level rise out of control. 2/3 of the world's population lives within 60 miles of the sea. The effects of the coming meltdown could be catastrophic.
Temperatures might be climbing slowly at the moment and sea levels might be climbing slowly, but things are happening on the planet which are going to accelerate those things so that we see a very rapid change. The whole system is going to tip and we're going to see catastrophically rising sea levels, dramatically rising temperatures.
The problem is that as temperatures continue to rise, weather patterns begin to change. The Earth has many processes that keep violent climate change in check. Even ice itself is part of the process that keeps the Earth cool. But some scientists worry that these fail-safes are breaking down, and planetary warming is out of control. The Earth is heating up, the ice caps are melting, and sea levels are rising. Human industry is the cause, and that should mean we can stop it. But recently, scientists have discovered a new problem. Global warming is damaging one of the processes the Earth uses to regulate its temperature. Ice reflects the sun's energy back into space, and that helps keep the Earth cool. Melt the ice, and there is less ice to reflect the sun. More heat is absorbed into the oceans, and the cooling effect gets smaller. As more and more ice melts, more and more heat from the sun gets through, melting more ice. It's a vicious circle. Sea ice geophysicist Professor Don Perovich is on a mission to understand how the interaction between sunlight and ice controls the planet's temperature.
When it's all said and done, what keeps the Earth warm is sunlight. And how much of that sunlight is reflected is a key parameter in the global climate system. Now let's do a little experiment. I've got these two boards which are identical, well, almost identical, except for one thing. And you can see what the difference is. This board is black, this board is white. The white board, the snow-covered sea ice, is the best naturally occurring reflector on Earth. The black board represents the open ocean, which absorbs most of the sunlight. So let's just do a little experiment now. We'll measure the temperature of these two. I've got this nice little thermometer. I pointed at it, and I can see that the temperature is 26 degrees centigrade, a little around 78 degrees Fahrenheit. Look at the blackboard, it's the same temperature because I just exposed them to sunlight. So what we're going to do is just take a couple minutes to see how the temperature changes between these two boards. Okay, let's take another temperature measurement. We'll look first at the whiteboard. The whiteboard, it's still at 27 degrees centigrade. Now let's look at the blackboard. The blackboard, it's increased to 48 degrees centigrade, almost 120 degrees Fahrenheit. Now this is a nice little experiment to do on a sunny day, but it also has ramifications for the Arctic sea ice cover. Because what we're doing as the ice cover retreats, as it's been doing for the past few decades, is we're replacing the snow-covered sea ice, the best reflector, with the open ocean, the worst reflector. And as a consequence, we've been putting a lot more heat into the Arctic system.
The measure of the reflectivity of a surface is known as its albedo. White ice has an albedo of 80%. Dark sea is around 20%. A snowball Earth would reflect 80% of solar energy back into space. An Earth with no ice would absorb most of it. And somewhere in between, there is a tipping point where there's not enough ice to counteract the heat being absorbed by the darker oceans. Global temperatures will rise rapidly. The last of the ice will melt, and sea levels will rise. Perovich wants to know when our planet will reach this tipping point, when the process becomes irreversible.
118.
He's worried it could be sooner than we think.
The concern is if you start to push the system too far, if you have a sequence of warm summers, you begin to shrink the ice cover by 10, 20, 30%, where you reach a state where it becomes exceedingly difficult to go back.
In 1979, the perennial sea ice cover of the Arctic was approximately the same size as the continental United States. By 2005, the equivalent of almost all the states east of the Mississippi has been lost. It's feared this recent retreat of the sea ice is likely to speed up so fast that all the ice cover may have gone by 2045.
If you look closely at this record, you can see that this retreat's been accelerating in the past few years. And if you look at that accelerating trend, the ice cover could be gone in as short a time as a few decades.
At present, it's not known at what point the process becomes irreversible. The melting of all the ice cover may already be inevitable. The destruction of the ice cover will have an even more immediate effect. We already know that the seas are warming. We know this will accelerate the melting of the ice sheets and push sea levels higher. But it will also have a dramatic effect on our weather. Heat is energy, and sea temperatures are the engine that powers one of the most destructive phenomena on our planet, the hurricane. Hurricanes use water vapor coming off the sea surface as their power source. As the vapor rises, it condenses into water droplets, releasing energy as heat into the hurricane. That's what makes them grow stronger. So as sea surface temperatures continue to rise in the hurricane breeding grounds of the Atlantic, Gulf Coast, and Pacific, hurricanes will increase in intensity. It's not just the power of the winds. In a world of higher sea levels, another danger comes from the huge storm surges the hurricanes bring with them. The duration of tropical storms and their maximum wind speeds have increased by about 50% since the mid-1970s. In the past decade, the world has seen the most powerful El Niño ever recorded, the most devastating hurricane in 200 years, and in 2005, the most active and destructive hurricane season on record. The Earth faces disaster. Scientists predict storms will intensify. In America, cities along the East Coast lie in the path of hurricanes. How long before one of them gets hit? The Earth is getting hotter. The ice caps are disappearing. And the seas are getting warmer and higher. It's a recipe for disaster. Warmer, elevated seas mean more hurricanes, more storms, and more flooding. Many of our major cities will be under threat. New Yorker and professor of geology Nick Koch of Queens College is concerned that powerful hurricanes hitting northern states will cause mass devastation.
People's minds are on hurricanes a lot now after Katrina, which was our first national repercussions. But people have to understand that a northern hurricane, the type that will hit from Washington to the Canadian border, has very different characteristics. It moves 2 to 3 times faster. And because it moves faster, the effective winds on its right side go way up. So even though it's a Category 3, it might have Category 5 winds on that side.
He's right to be worried. Cities like New York are vulnerable to flooding. In December 1992, a powerful northeasterly storm gave New Yorkers a taste of what it's like to be inundated.
The destruction that it did along the shoreline was easily equal to a low-level hurricane. Winds at one point reached hurricane level.
The worst hit area was the coast of Long Island, where houses were literally dragged into the sea.
It was an immensely powerful event that did tremendous damage along the shorelines.
Downtown Manhattan was underwater. floodwater shorted out the entire New York City subway system.
All our subways and highways and railroads have what we call choke points, points where they reach low levels, and those choke points were flooded, and there was massive dislocation.
LaGuardia Airport closed. Parts of Manhattan lay under 4 feet of water, and wave height reached 24 feet at the shore. But this was simply a bad storm. Koch fears that with sea levels rising, a strong northerly hurricane could flood much of New York.
The New York, New Jersey metropolitan area is one of the most dangerous places to be in a nor'easter or a hurricane for a simple reason.
The problem is geography. Long Island and the New Jersey shoreline create a right angle. If a hurricane approaches New York, the counterclockwise winds would force a hump of water into that coastal right angle.
You can't push water into a right angle without it rising.
As the water is forced into the narrowing gap, it rises fast.
We're talking about a storm surge rise at the Statue of Liberty of 22 feet and 28 feet in Jamaica Bay.
This massive wall of water would breach the coastline and race into the city. The last strong hurricane to strike New York was in 1938, causing 600 deaths and $5.4 billion of damage in today's money. But as sea levels rise and hurricanes increase in intensity, it's only a matter of time before New York is struck by a big storm. No borough would be untouched. Hundreds of square miles would be flooded. New York would cease to function.
There is no service in the city at this time.
John F. Kennedy Airport and Battery Park would be under 10 feet of water. The subway would be flooded and hundreds of buildings severely damaged. Rebuilding would cost hundreds of billions of dollars. Parts of the greater New York City metropolitan area, presently home to more than 20 million people, would be forced to evacuate. It would be a catastrophe on an unimaginable scale. Global meltdown. It's a bleak vision of the future, but scientists believe it is inevitable unless we act. Our world is changing beyond recognition, and we humans are making it worse. The ice caps are melting, and sea levels are creeping higher and higher. Worse, it appears that we are moving ever closer to a tipping point, beyond which we can't stop it happening. But there is hope. Some scientists believe that if we act now, we might just stop the meltdown before it's too late.
Let me show you something really cool. This is the history of lead concentration in snow falling in Greenland. And in 1750, we're starting to use a lot of lead in the Industrial Revolution for batteries and paints and so on. And we see the lead that we're using showing up and spreading around the globe, showing up in Greenland. And we start putting it in more things. We start putting it in gasoline to make our cars work. Then we had the Great Depression, and we had World War II, and the economy goes down the tubes. And then we get really serious about putting lead in gasoline and running our motor cars around. And then we said no. We said, hey, too much lead in our cities, too much lead in paint and gasoline is making us stupid. It's making us sick. It's bad for us. We have to clean this up. And we did. We got the lead out, and it's really beautiful that this worked. And so what one sees is that we humans really can mess things up. We can foul our nest. And when we decide we want to, we really can clean it up.
We stopped pumping lead into the atmosphere, and the atmosphere changed. Could we do the same with carbon dioxide? By investing in renewable energy sources like wind and solar power, and cutting greenhouse gas emissions, we could perhaps begin to clean up the atmosphere. Maybe we can avoid pushing the climate past the point of no return. It's going to be hard. But the consequences of failure are truly terrifying. If we fail, tomorrow may bring an unrecognizable world of social and economic chaos, human tragedy on an appalling scale. Or if we act, it may bring little change at all. The choice is ours.